Long division, the rules are D, M, S, B. Divide, multiply, subtract, bring down. Okay, so how do we divide? When we divide, we take the first term divided by the first term. So that will be x squared divided by x squared, which is equal to 1. You write the result directly above. The next step is to multiply. What do you multiply? You multiply the results, which is the 1 times everything here. So it's going to be 1 times x squared plus 1. 1 times x squared plus 1 is x squared plus 1. So it's 1 times x squared, which is x squared, 1 times plus 1, which is 1. So we divided, we multiplied. The next step is to subtract. So how do we subtract? Now it's top minus bottom, so you change the sign of the bottom term. So now if it is a plus, you change it to a minus. This is a plus, so you change it to minus. Now you need to be careful when you are subtracting. If you have an x squared on the top, there must be an x squared in the bottom. If you have a constant in the bottom, there must be a constant on the top. You write it in order. So clearly you cannot see the constant. But what is it? It's a 0. Okay, it must be in line there, otherwise you'll make a mistake. So now 0 minus 1 is minus 1. Then we got 1x squared minus 1x squared. That's 0. It will cancel out completely. So now this is called the remainder. Normally you will, if there was maybe x squared again, it depends on the question. We did it, I think we did an example, but just one in N5. When we come to partial fractions, then we'll deal with this again, long division. Alright, so you normally go and divide until it's impossible to divide. So what just happened here? We have taken x squared over 1 plus x squared, and we rewrote it, or we divided it, and the result was on the top here, which is 1 plus the remainder all over the denominator, always. Okay, so what was the remainder? It was minus 1 all over the denominator, which is 1 plus x squared, or x squared plus 1. It doesn't make a difference. So how do you know that you did not make a mistake? If this is equal to that, the left hand side must equal to the right hand side. So you can substitute a value for x here. On the left, you can use your calculator. You don't have time to go and find the LCD. If you want to, for your understanding, you go and take the right hand side, you simplify it, find your LCD, you'll see it will come to the left hand side. But in the exam, you don't have time for that. You take a value, you substitute into the left, you get an answer. And let's take an example. If I take 2, if I put 2 in place of x, 2 squared is 4, 2 squared is 4. So that's 4, and 4 plus 1 here is 5. That means if I substitute 2 here, the result of the whole thing must be 4 over 5. Then you know you're correct. So now let's write it down here. So how are you going to write this out? This is minus 1 over 2 times the integral of x squared over 1 plus x. So it's times the integral of, now remember, we changed x squared over 1 plus x squared. We rewrote it as 1 plus minus 1 over x squared plus 1, or 1 plus x squared. Doesn't make a difference there. So it's now 2 fractions instead of 1. So now, we can integrate 1 with respect to x, which is just x. Now we need to integrate. Okay, now it depends on if you want to multiply a positive times a negative, which is a negative first, and then integrate, you can. Or if you do it as it is, then we now have minus 1 all over x squared plus 1. We need to integrate this. How do we do that? So now remember, this looks like it's almost the same. Can you see that? So if we differentiate inverse tan, we get 1 over 1 plus x squared. If we integrate 1 over 1 plus x squared, what is the answer? It's inverse tan. It's a reverse process. Forward is 1 plus x squared. Reverse, you integrate, you get inverse tan. Now, if there's a minus here, what will it be? You're going to integrate minus f prime x all over 1 plus f of x all squared is going to equal to inverse cot. The only difference between inverse tan and inverse cot is the minus sign. The only difference between inverse sine and inverse cos is the minus, and the other two, inverse sec and inverse cosec. Okay, there's 6. The only difference is the minus sign between those. So now you can, what did you just do now? I looked at minus f prime x all over 1 plus f of x all squared. So this will remain as a plus because this whole thing here is now inverse cot. Plus c, or let's assume that you did not, you multiplied first. So what did you do now? You realize there's a plus, there's a minus there, so you went and wrote it as positive times negative is a negative. So if I change this to a negative, that means we now have just 1 over 1 plus x squared, which is going to be inverse tan. So both versions are correct. You can see this one has a plus, that's a minus. Yeah, and I wrote down my integration sign again. Right, so the only difference there is the signs. If you want to multiply out, you can, but it's unnecessary. So that's x squared over 2 inverse tan of x. So that will be minus half x. Negative times negative will be a positive half inverse tan x plus c. That if you are using this O here, that will be x squared over 2 inverse tan x minus half x minus half inverse cot of x. Okay, so remember there's 2 different versions here. We are looking at this and that. Right, so you can see you needed to know your inverse trig functions, differentiation and integration, both ways. You needed to remember your long division from grade 5.